Hi, thank you.
Hello.
Hello, everyone.
Happy to be here and talk to you about building serverless web applications with Blazor. I'm Daria Grigoriou, and I work in the Azure Functions team in the program manager role.
I'm Fabio Cavalcanti. I'm also on the Azure Functions team in the engineering team for Functions.
When we talk about serverless web apps, we're really talking about the concept of distributed microservices. This is a design pattern and architecture, and the two main components that we're going to focus on today are the client front-end experience, basically the implementation of a web app with static content and without web servers, and the dynamic backend implemented with serverless APIs. In the context of realizing this design pattern specifically with Blazor WebAssembly, let's just revisit the elements. With the distributed microservices, you can enjoy independent development, independent DevOps lifecycle, which makes versioning really easy. You can also mix technologies, programming languages, hosting platforms, and this way you get fault tolerance and really good granularity in your development. Now when we go to the client, the front end, you can use Blazor WebAssembly to create rich web apps. They have reusable UI components that are running directly in the browser. You can implement your dynamic backend, your serverless API with Azure Functions, and this way you get high productivity development, especially with our programming model that is able to streamline development. And you also get the benefit of adaptive scale, dynamic scale that is based on events, which enables you to pay only for what you use.
So how do we go about designing some of the serverless solutions? How do we take an application, a Blazor app, and designing that to leverage some of the serverless offerings that we have? So we want to start out with this very high-level diagram, a very high-level overview of how we are breaking up this application into the different components that we're using as part of the overall solution. So we continue to have our Blazor app, but now the Blazor app is being served up, all of the static content is being served up from Azure Storage. We're deploying there, that is eliminating the need for us to have a web server in place. So we're getting all of our contents when the user first comes in and issues a request on the browser. That's how they're getting the Blazor app to run locally. Once the Blazor app is now running in my browser, all of my API calls, all of the communication, in this particular case to retrieve the data that we need to provide the information requested by the user, is being served up from an Azure function. So we're exposing a set of different APIs from Azure Functions, which is now also abstracting away a couple of different serverless services that we have in Azure, namely, in this case, Cosmos DB and Cognitive Services. So if we start diving into looking into each one of those components, you've been hearing about Blazor all day today, but we thought we'd have a quick recap here, just talk a little bit about what that's giving us. So we have a reusable a framework that provides a way for us to build reusable UI components that are implemented in C#. They are written in .NET, our language of choice, the language we're familiar with. .NET combining that with HTML and CSS for UI. We're running .NET in WebAssembly, and that gives us the ability to leverage the rest of the .NET ecosystem. Not only giving us the ability to consume dependencies available in .NET, but also use common .NET patterns and all of the .NET tooling that we are familiar with. We're combining that with Azure Functions. So if we start looking at Functions, Functions is really a service that gives us the ability to react to events and write our business logic and all of our code to react to what we call triggered events. Those events can range all the way from an HTTP request and something as simple as a queue message on storage, all the way up to a change feed and document change notification from Cosmos DB. When we combine that with the pre-built integrations that you have as part of the function service, you have the ability to react to those events, focus on your business logic and generate, taking input that comes from some of the pre-built integrations we have, but also generate output that will talk to storage, Cosmos DB, and a number of other pre-built integrations that we have in functions. And we typically refer to those as bindings.
And the bindings are an ever-growing list. So you can check back in a little bit of time and you'll see the list that is continuing to grow.
So when we're leveraging and using bindings, what does that programming model look like, right? So we have a quick example here, which is actually taken from the demo app we're going to be walking through during the presentation, showing how we are actually using Cosmos DB in this particular case. What you'll notice here is that we have a declarative model where I have the ability to configure my binding, and I can continue to focus on my business logic, the logic that matters to the problem that I'm trying to solve. In this particular case, you'll notice that we're not using the SDK directly. I surely have the ability to do so if I wish to do so, but having the ability to just leverage the binding capability gives me that productivity boost. In this particular case, we're just working with a document that's been provided as an argument to my function. So you get the same kind of benefits that you get from Blazor in functions. That familiar development experience, you have the ability to use your Visual Studio as your primary IDE, the .NET tooling. This is running on top of .NET Core. So you get the full power of the .NET ecosystem, the ability to consume dependencies, bring in anything that you need in order to solve the problem that you're trying to solve within functions, and take advantage of those dependencies, and the ability to continue to use the same patterns that you typically use in your other .NET applications. For example, things like dependency injection, which we'll take a brief look at a little later.
It sounds like Blazor and Azure Functions fit well together.
It's a great combination, yes.
To illustrate some of these concepts, let's go to a demo. The demo for today is implementing a question and answer game. And this question and answer game, of course, is implemented using Blazor, especially for this context, Blazor WebAssembly. And it calls into an API powered by Azure Functions. So we can ask a question here, like, what are Azure Functions features? And we see an answer about the key Azure Functions features that we can go and read. This is coming from our interaction of Azure Functions with Cognitive Services Q&A Maker from a knowledge base that we already populated with serverless specific topics. Now, we actually want to use Azure Functions to abstract the different kinds of services that we're working with. So we also created the ability to generate answers based on keywords. So one of them is meaning. So let's ask, what is the meaning of life? Easy question. And if you don't like the answer, you can ask again and again until you find something that you like. So I'm going to settle on this one. I think serverless technologies may not be the meaning of life, but they can make your life more meaningful and more productive. I'm happy with that. And I just want to call attention to the fact that here, functions is really wrapping a multitude of services and really being able to abstract complexity and distribute business logic across all of those. Another thing to notice here is that we are going to Azure Front Door, which is aggregating my client and my API. So we'll talk more about that later. Now, how did we make that happen? And one interesting point is to look at the inception of the developer experience. So here we have both the client and the server running in Visual Studio. And we have Blazor WebAssembly calling into our API. And then we have our Azure function here. And Fabio talked earlier about the programming model. So you notice here that we are using the Cosmos DB binding, and we're also calling into the Q&A service. So what we can do is we can run this locally. It's actually already running. And I can even set up breakpoints and work with the local debugging experience. If I go back here, I have this running locally. So I'm going to ask another question. What is Blazor? Let's submit. And we have a breakpoint here. And I can go and I can debug, I can work with this answer. I don't like this answer, so I'm going to change it to Blazor is a great idea. Let's continue. And there we go. So what is really interesting here is that this is not running an emulator for Azure Functions.
Right, right. When you run locally, you're really running against the same exact runtime packaged with a set of tools that we make available for a local development experience, but it's the same exact runtime that you will be running against if you deploy your application to Azure, which gives you a full fidelity environment, right? It gives you that assurance that if something is working locally, if you validate that things are working against your local set of development tools, they'll likely continue to work as you deploy. So you're running against the full end-to-end runtime. One of the things that I did notice here is that, yeah, you're highlighting the fact that we're using a feature here, injecting our service directly. So it's just an example here as part of your service in your code, where you are using some common .NET patterns that you may be familiar with in contexts outside of functions, and you're registering that service and using that from functions. So anytime your function executes, that service is automatically injected, giving you the ability to just manage that service and use that directly from your function and have the lifetime of that service managed by functions itself.
And the other thing that we mentioned earlier is that you really don't need to learn all the APIs and SDKs for services that you want to bind to, which is the case with Cosmos DB here as well.
Right.
So you can notice that I'm just being very direct in how I write my code and referencing this really without any kind of SDK or API interactions.
Right, there's very little in this code that is specific to Cosmos DB, right?
And this goes back to the point of really being able to focus on your business logic. So now that we looked at the local development experience, let's go back to the slides for a moment. And let's just move on to how do we host all of these components for serverless web apps in Azure.
So for this particular example, this particular demo, as we saw in the initial diagram that we had, we are using a couple of different serverless options from Azure. So we have a couple of different services to interact with. The first one being Azure Storage. We're using a feature of Azure Storage that gives us the ability to host static content, which works very well for Blazor WebAssembly applications, right? So as we deploy the static assets to storage, and that's where the initial requests are going to. When the user comes to our application, they are requesting the files that we need to run to load that and run that Blazor app, and that's all coming from storage. So the important thing to keep in mind here is that it completely eliminates the need for me to stand up and maintain and run a web server, right? So that's completely taken away and abstracted away by this feature of storage. And the next service being Azure Functions, which is hosting all of our APIs, all of our dynamic content, all of our custom logic that's running on the server side is coming from Azure Functions. That's also providing some of the abstraction over some of the other services Dario just mentioned. So when we're communicating with Cosmos DB, or cognitive services. That's all happening from within functions. So the information on how to communicate, how to connect to those services is maintained on the server as part of those APIs. And that's giving you the dynamic scale capabilities, is giving you the billing model that you have the ability to take advantage of because of the nature of how those serverless offerings function. So in this particular case, for functions, if I have no load, what's going to happen is that my function is going to be idle. There's absolutely no code running. And what we see here is that we don't have your app loaded and executing any code, which what that means to you is that you're not paying anything for that code. So if there is no traffic, you're not spending any money with the infrastructure. The infrastructure is handling all of the scaling, the dynamic scale for you. So as soon as that first user comes in and we see that first request, the infrastructure will automatically stand up an instance of your Azure Function app and make those APIs available to that user. And that's going to happen and continue to happen as more users come in and we see that the load is increasing. We'll continue to increase the scale. We'll continue to automatically scale that function app to additional instances to keep up with that demand, to keep up with that load. The inverse will also happen. As the load goes away, as our app is no longer being used, we'll scale that application down. And you're only paying for the time and the execution of your functions. That gives us the ability to have that very flexible billing model because of the dynamic and automatic scaling that you can enjoy when using some of those serverless offers.
And this should help your application be more successful globally. And as you get more end users, you can expect them to be globally distributed. So what do you do to optimize their experience to ensure fast delivery of that content and reduce the latency? And there are a couple of options in Azure that we decided to call out. The first one is Azure CDN. With Azure CDN, you can cache content near the end users for fast delivery, and you can also manipulate HTTP at the edge, the request, the response, with the help of the rules engine. So Azure CDN is a great pattern to use when you have static content. Now, if you have something similar to this example where you have a lot of dynamic content, a mix of static and dynamic content, a good choice for that is Azure Front Door. Azure Front Door provides dynamic app acceleration, and it provides this global load balancing with near real-time failover. It has points of presence that essentially allow you to achieve that low latency and fast delivery. And then it also allows you to leverage the URL-based routing and redirection for dynamic content. We talked about the resources in Azure that compose our solution. And it would be interesting to actually visit them and explore, first of all, how they get delivered, and then what they look like. And specifically, let's focus on the example of our Azure functions. Here we have our function app. This is the repo where I've included an Azure pipeline definition. So this is my YAML file that defines how to build and how to deploy. In this case, we're archiving and deploying the package to functions. And you can see the pipeline. You can see the different executions that we went through. And you have the opportunity to go and inspect the different actions and results that were provided part of that pipeline. So now you can see this was a successful deployment, and it resulted in the content being deployed to our Azure Functions resource in Azure. And for this specific solution, because we're building a serverless web API, you can see that on the management plane we have cores, roles defined, and also, just going back to the point that we talked earlier about, we have this deployed through the pipeline, so you can see the status here as well. However, this is a composed solution, so here is my resource group with a bunch of different resources that compose this solution. And as I mentioned, we are using Azure Functions to abstract the connections and business logic with other services as well. So this is my Cosmos DB, and you can see I'm storing different answers that I can provide to my end users. And this is my Q&A maker with the knowledge base that we pre-populated to address serverless topics. And tying it all together is Azure Front Door. Here you can define your front-end hosts. You can include a custom domain if you go beyond the demo step. And then you can define your backend pools that are referencing the services that are actually composing the solution. So I pointed this to storage, and I pointed the backend to my Azure Functions. And I also created routing rows that essentially enable me to define how I want my end users to see the client. And then I can even define rows that point me to the API directly, unified under one URL, because I don't want to expose the different resources that compose the solution to my end users. So let's go back to our slides here and talk about what more value we can add with this pattern.
Right, so let's talk a little bit about how we go about enhancing one of those apps, right? So we just took an application that we broke it down to a couple of different components that are hosted in different areas, different places in Azure. So let's look at what we can do to enhance this. When we were thinking about that, a very clear option was some real-time communication, some real-time features. So leveraging a topic that has been covered today using SignalR. So we decided to leverage yet another serverless option on Azure using the SignalR service. The very nice and convenient thing is that there is a pre-built integration for a SignalR service in Azure Functions as well. And making that process extremely simple for us. So the pattern that we're going to be using here, we have our function will be posting messages to the SignalR service anytime a new question is asked. So anytime we see any user using our application posting a new question, that question will be published as an event. That event is actually going to all of the clients that we have connected at that point in time. So if we look at the diagram, we have a persistent connection between the client and the SignalR service. This is a bidirectional connection. And we're sending those events to the client, giving us the ability to have some insights into what other users, how other users are using our app. So let's take a quick look at that. So what we're going to do here is Daria has a new version of the app that we've been looking at that's been enhanced with that capability. I have the same version of the app here on my machine. So what I'm going to do is I'm going to submit a question to the service, and what we're going to be able to see is that Daria was able to see that question, that recent question that just popped up that's being asked.
And I didn't do anything.
Her hands are off the keyboard, and this shows the real-time communication and the push from the server to the client. So the clients now have the ability to see those real-time messages, see those questions coming from all of the different clients that are using functions as the API. My question here was asking how we could use the Azure SignalR service from Azure Functions. So instead of just talking about it, I thought it would be a good idea for us to show the code that we had to write to make that happen. We actually have a PR open against Daria's repo, and we can see here that we had to touch a couple of files, but the core change that we had to make was really to use that declarative programming model using the bindings that we talked about earlier to leverage the SignalR bindings. So we had to reference that binding. Is a pre-built integration that I have the ability to reference from my .NET project, my function project. We have this additional argument as part of my function that's being decorated with a SignalR service attribute, essentially with some basic configuration and metadata to define how that binding is going to work. And I have just a few lines of code here to add a message to the service anytime a new question is asked. So that was really the extent of the change that I had to make from a functions perspective. That's really all I had to do to enable the capability as part of my functions, as part of my APIs.
And oftentimes we talk about using just a handful of lines of code to accomplish really complex tasks. And in this case, we've enhanced the application with real-time communication. And the functions runtime is doing a lot of the heavy lifting for you.
Right. There is some additional code on the client to connect and keep that persistent connection. But from an API perspective, the change that I had to make to my function in order to enable the capability is really all there is to it.
So let's just recap for a moment, because we have a few concepts that reference back to this demo.
Right. So what we've been able to see is that functions abstracts away a lot of the complexity that would otherwise live on the client. So all of the communication, everything that we're doing against Cosmos, against cognitive services, and now against SignalR has been abstracted away from the client. The client doesn't have to those are concerns that have been removed, and you don't have to worry about the logic on the client anymore, giving us the ability to also manage that independently. We've been able to leverage these pre-built integrations. In this case, we've been able to show how we've used the SignalR extension and binding to add that new capability to our API. And we also wanted to show that a serverless solution may be comprised of a lot of different services. You're not restricted to one option. You can combine several services like functions, in this case, storage, SignalR service, DocumentDB. Logic Apps is another great option of a serverless option that is often used in conjunction with functions. So you have a lot of options, and typically a full end-to-end serverless solution is comprised of a lot of those services.
So now that we've talked about each of these components and demos and concepts in isolation, we have a few takeaways. The first one is that you can really leverage the power of distributed microservices to create complex serverless web apps that are really not that complex to implement. The client front-end experiences have a great opportunity in the form of Blazor WebAssembly. And to get started with that, you can go to AKMS Blazor WebAssembly, and that's a good starting point. The dynamic backend content can be implemented with Azure Functions for your serverless APIs. And to get started, you can go to AKMS Azure Functions. Also, if there are any questions that we won't get to answer today, we have our contact information presented on this slide as well.